Aurora borealis in Romania, who would have thought? When I was a child, I read that they only appear near the North Pole. Recently, photos of the Aurora borealis taken in January in Romania have filled Facebook pages. What's happening? What has changed? Is it something serious? Watch the video until the end. I will explain in a way everyone can understand, but with some technical details, how auroras form, why they can come down to mid-latitudes, why they can be seen in Romania, what colors appear, and from what altitude these lights come. And most importantly, I will answer the question, what is special in Romania right now? Our grandparents have seen something like this. The northern lights in Romania are caused by the solar wind. There is no wind blowing in space, but that's what we call the electrically charged particles that the sun throws into space. Normally, the Earth is constantly hit by the solar wind. Its particles first reach the Earth's magnetic field, the magnetosphere, which acts like a kind of cosmic shield, protecting both us and everything else. Thus, once they reach the magnetosphere, the particles of the solar wind, especially electrons and sometimes protons, are guided by the magnetic field lines toward the polar regions. The guidance is done through the Lorentz force, the magnetic force that acts on an electric charge. This force causes electrically charged particles coming from the sun to follow spiral trajectories around the magnetic field lines. Thus, the particles end up moving toward one of the two poles, guided by the magnetic field lines, which also concentrate at the poles. The particles enter the Earth's upper atmosphere and collide with the atoms and molecules there. As a result of these collisions, the atoms and molecules become energetically excited. And when they return to their normal state, they emit photons, meaning light, just like in a neon tube, where a gas glows when it's bombarded by electrons. That's why normally we only see auroras nearby. The one in the north is called the Aurora borealis, and the one in the south is called the Aurora australis. Seen from the Arctic region, auroras sometimes appear like curtains. Why? Because electrically charged particles are guided by Earth's magnetic field lines like invisible rails instead of spreading out evenly. They are concentrated along preferred paths, and when these paths are long and close together, we perceive them as a luminous curtain. The curtain has vertical folds because the electrons don't enter the atmosphere in a perfectly smooth layer. They descend in several narrow, almost parallel channels, aligned with the direction of the magnetic field. Each channel lights up a thin strip of light, and together the strips give the impression of a curtain that ripples. Why curtains and not something else? Because the final shape is the result of the complex interaction between particles, Earth's magnetic field, and the plasma in the upper part of the atmosphere. These interactions can organize the particles into fine structures that move and ripple, and the exact mechanisms that create these channels and folds in all their details are still an active subject of research. In the end, the places where the particles descend most intensely change rapidly. Field-aligned currents, electric fields, and waves in the magnetosphere modulate these channels, and the bright sheet ripples and flutters like a curtain moved by a draft. How is it possible to see the Aurora borealis from Romania? It is possible during strong geomagnetic storms. Geomagnetic storms occur when the solar wind erupts on the sun under conditions favorable for a strong interaction with the magnetosphere. Usually, what happens is that the plasma cloud coming from the sun, made up of ions and electrons, is much faster and denser than the usual solar wind. And especially when the magnetic field of this cloud has a specific orientation, basically, the sun sends a much denser and faster package of electrically charged particles. For example, through a coronal mass ejection, when this plasma cloud reaches the Earth, it interacts with the magnetosphere. If the orientation of the magnetic field produced by that jet is suitable, a disturbance occurs in the Earth's magnetic field in that area, allowing the particles to penetrate much more efficiently toward the atmosphere. In this case, a lot of energy is injected into the magnetosphere, and the geomagnetic storm is triggered. Basically, the energy injected into the magnetosphere is so great that the particles are accelerated. Then, they also move toward lower latitude regions. A key factor here is the geomagnetic auroral planetary index, which measures how disturbed Earth's magnetic field is. Kp is a number from 0 to 9. 0 to 2 means calm. 3 to 4 is moderate activity, 5 to 6 is a geomagnetic storm, and 7 to 9 are severe storms. The higher the KP, the further south the northern lights extend. On calm nights, the northern lights are only visible in the Arctic region, but at a KP index of 7 to 8. They can also be seen in Germany, Poland, Ukraine, and in extreme events, even in the Balkans. This is the key for Romania. The area where the auroras occur extends to the south. There were auroras in Romania even during our grandparents' time, which is the main reason why we are seeing more auroras in Romania now, while our grandparents saw fewer, because they didn't tell us much about them. It's not physical, but technological. Mobile phones and high-performance cameras. War. Our eyes are excellent at detecting movement and contrast, but at night they don't gather light like a camera sensor does. A phone in bound-up night mode or a camera with a few seconds of exposure reveals shades that the eye barely perceives as a faint spot. That's why, when looking at the northern lights from Romania, some people say they couldn't see much, while photos suddenly show an image with many contrasting colors. Elevated. That doesn't mean the aurora didn't exist, but that the event was real, just weaker for the human eye in Romania. In addition, professional photographers use cameras capable of long exposures, which is why the number of photos increases. And it seems like the northern lights appear more often or more spectacularly than in the past, but the same northern lights happened in the past as well. In fact, with cameras, our ability to observe and document them increases. However, mobile phones are not the only explanation nowadays. Another reason is the fact that the sun goes through activity cycles of about 11 years. The current solar cycle has just passed a maximum. Thus, in October 2024, the sun reached the solar maximum period for the current cycle. Near the peak of solar activity, the number of sunspots increases significantly, as does the likelihood of solar flares and coronal mass ejections. These in turn have a higher chance of causing stronger geomagnetic storms and thus also generating auroras at lower latitudes, as is the case in Romania. Why have most of the auroras observed in Romania been red? One of the most fascinating things about the aurora is its palette of colors. Many people expect a bright green, but in Romania, shades of red, pink, violet, or even whitish have often been reported. The colors are not random. They depend on which molecules are excited and at what altitude the collisions occur. The intensity of the colors also depends on the camera used. The intensity of the colors depends. The main gases that emit light in the aurora are atomic oxygen and the nitrogen molecule. Each has specific spectral lines, meaning they emit light at precise wavelengths, which is why the colors are quite consistent. The green, which is often photographed in Arctic regions, comes especially from oxygen atoms found at altitudes between about 100 and 200 kilometers. As a result of the bombardment by particles from the solar wind, these atoms reach a high-energy state. We say they are excited. When they de-excite, the atoms emit light with a wavelength of 557 nanometers, which corresponds to the color green. On the other hand, the red color of the auroras is also caused by oxygen, but by a different transition, usually at 630 nanometers, and it appears at higher altitudes above 200 kilometers. That's why in the Arctic regions the red color is often seen higher up in the sky, while the green is seen lower at lower latitudes. The energy of the particles entering the atmosphere is lower because the area is farther from the North Pole. With less energy, the particles generally stop in the upper part of the atmosphere. That's why the auroras observed in Romania are predominantly red, because this is the color generated at high altitudes. However, we usually observe them not directly overhead, but lower, near the horizon and always towards the north, because in reality, that's where the impact occurs. Similarly, there are also cases when aurora appears violet, blue, or pink. These are associated with nitrogen to summarize the colors and altitudes. Here is a sketch that summarizes the colors. Red above 200 kilometer oxygen, 630 nanometers green, 200 kilometer oxygen, 557 nanometers blue-violet, 91,120 kilometer nitrogen, pink below 100 kilometer nitrogen. In reality, auroras are not a uniform layer. They are more like a three-dimensional volume, with structures in the shape of curtains, arcs, and spirals. That's why the colors can appear layered, green at the bottom, red at the top, and sometimes violet-blue in the lower parts or at the edges, depending on the composition of the atmosphere and the altitude of the emission. The lower limit where the aurora borealis forms is usually around 8,100 kilometers, and the upper limit can go up to 300-500 kilometers depending on the event. That means the aurora is an upper atmosphere phenomenon, far above the clouds and airplanes. The fact that the aurora borealis can be at an altitude of 200-300 kilometers explains something important. The aurora borealis doesn't have to happen exactly above Romania. To be seen from here, it can be visible even from hundreds or even thousands of kilometers away. That's why in Romania, auroras have generally been photographed as reddish streaks toward the north, not as a direct spectacle overhead. In other words, even if the aurora borealis occurs in Ukraine or Poland, there are real chances that the upper part of the aurora, often red, can be visible, even from Romania. We were surprised to see the auroras recently in Romania, but auroras haven't only started appearing at low latitudes just recently. There have been other episodes in history as well. One of the most well-known is the geomagnetic storm from January 25-26, 1938, when intense red auroras were seen in most of Europe, and people mistook the red sky for a fire and called the firefighters. Another famous event is the Carrington event. From 1859, the most powerful geomagnetic storm documented at that time, when auroras were seen as far as tropical regions. There were serious effects on the telegraph infrastructure. It's an example of how solar activity can directly influence the Earth. Closer to the modern era, there were also geomagnetic storms in 1989, famous for the blackout in Quebec, the Halloween storms of 2003, and the events of 2015. In 2003, auroras were observed much further south in Europe, and space technology and electrical infrastructure suffered. The recent events are also very interesting, such as the geomagnetic storm in November 2023, when auroras were reported in Romania, Bulgaria, Italy, and in other countries further south than the classic area. Auroras were seen in Romania in January. Why? 1. A coronal mass ejection occurred. 2. This in turn produced a strong geomagnetic storm. 3. The electrically charged particles from the solar wind ended up hitting the upper atmosphere even at lower latitudes, such as Ukraine or Poland. 5. The upper reddish part of the atmosphere at high altitudes became visible to the north, even from Romania, due to the oxygen emissions lighting up at very high altitudes above approximately 200 kilometers. 6. In many of the photos, the red appeared more intense than in reality because the camera gathered light over time. Longer exposure, higher International Organization for Standardization and Additional Processing. An example is the evening of January 19, 2026, and the night of November 5-6, 2023, when many photos appeared on social media, especially from Transylvania and Moldova. In such cases, the camera, with longer exposure and higher sensitivity, captures the colors much better than the naked eye. What were the causes? Episodes of increased geomagnetic activity related to intense solar wind and disturbances of the magnetosphere? Fortunately, for people on the ground, auroras are not directly dangerous. The energy is dissipated high up in the atmosphere. However, they remain a sign of a geomagnetic storm, which can affect satellites, global positioning system, radio communications, and even power grids. The northern lights visible from Romania are not a miracle nor something paranormal. It's physics, but also technology. The same phenomena occurred 1,000 years ago, but people didn't have mobile phones and advanced cameras to photograph them. The approximate duration of these storms can range from a few hours to several days, with the maximum effects often occurring around midnight. And for Romania, it's worth checking the direction to the north in an area without artificial light. Personally, I checked it about 3 hours after the recent event, but I didn't see anything. If you saw something, please write it in the comments. In the end, I want to thank those who support me here and on Patreon. On Patreon, you can get direct answers to your questions. Until next time.